What's the original one for 5 or 10?
5, 150.
Now I said don't worry about graphing it out, but maybe graphing it out gives you at least a good physical idea what's going on. So 5, 2. I'm not going to draw all the circles, but it's going to be 150 degrees right there. Okay. All right. So here's what I tell you to do for this one. I think it's easier for the first one. 150 would be positive angle. What would be your negative angle? Going this direction, it would be negative 210. Now, when you have a negative R value, you got to think of the point that is through the origin on the other side. So it's 180 degrees away from it. Okay, so you got to go through the origin. Well, how do we label that angle? If you're going to go positive, it's going to be 330 degrees. If you're going to go negative, it's going to be negative 30 degrees. So your other two answers are negative 5, 330, and then negative 5, negative 30. So really you got to figure out, all right, how do I get to this point? Because since the negative, we'll flip it back over to the other side for that one. Does that help a little bit?
So the 2 negatives point is just going to be the smaller angle of the negative 5 one. That's always.
Well, it depends on what. Let me think of something here. If I give you, all right, so let's take a look at the point. 460 degrees. All right, what would be our other values for 460 degrees? So it would be 1, 2, 3, 4. It would be right about here, right? And so the other point, when it's negative, is going to be down here. So 460 degrees, that is 60. The negative angle would be negative, what would that be? Negative 300? For negative 300. All right, now how do you get to this point here? What would be the positive angle? The positive angle would be 180 plus, that's going to be 60. So it's going to be 240. So it's going to be negative 4, positive 240. And then the negative angle would be here, which would be negative, that's 90, and that should be 30. So negative 120. So negative 4, negative 120. If you take out the negative, what are those two angles going to have to add up to? 360, because you're going one way, half the distance or half the angle, and then half of 360, and then you're going the other way, the other half. So they got to add up to 360, 60 and 300, depending on which direction you're going, and then 240 and 120 will give you 360, because you've got to go the full 360, start in one direction and then the other for that one. Okay. Other questions? Okay, we're good? Good. All right, we're going to finish up those notes. We're going to graph us some polar functions. There we go. What are you doing, Heather? You stealing my thunder?
That. Yeah, decimals.
Wait, I didn't think you could do that. I thought it had to be a whole number.
No, 0.5 factorial is greater than 0.5.
Hey, we're going to at least take initially the same approach as you do with any graph. You find a table of values, you plot them, you connect them. Now this is going to be with a smooth curve, so just make sure everything you graph has a curve on it. Don't try and connect them with straight lines. So we're just going to make a table of values. Was it given an R theta? So honestly, our table of value is actually going to be backwards because you're used to like for X, Y, you're used to plugging in X and getting back Y. We're actually going to plug in theta and get back R. But it still goes in the order R theta. All right, so that should be the equation. R equals 2, 1 plus cosine theta. All right, we're just going to type them in to begin with. So for the first one, this is your degrees on top. This is your degrees on top. So just do 2 times 1 plus cosine of 0 degrees. Now that one, you know, if you think cosine is 0 degrees, should be 1. Okay, and then that's going to end up being 1 plus 1, and in the end, you get 4. Okay, so you're multiplying 2 times 2, so we get 4. Now, it is okay. I do not need exact values. Go round to the nearest tenth is fine, because I know the cosine of 30 is square root of 3 over 2, and you're just dealing with all that stuff. Round to the nearest tenth. Go to 180, which would be the first one on that second row, and then stop. Just type them in, see what you get, go to 180. Tyler, you done? All right, what do you got for 30?
3.7,
Okay, 45?
3.4,
Okay, keep going.
3, 2, 1, 0.6, 0.3, 0.
All right, let's just plot those to begin with to see what's going on. So at 0 degrees, R is 4. So you got that point out there. Now technically the ordered pair would be 4 times 0. And the next one is 3.7, 30 degrees. Go ahead and estimate 1, 2, 3, 3.7, 30 degrees. Now 45 degrees is not a spoke. It's going to be halfway in between the 30 and the 60. And that's going to be 3.4. So graphing that. And then the next one is 3. What did we say? 2. 1 was 120. What's 135? 135 is 0.6, 0.6. And then we get 0.3, and then we get 0. All right, so those are your points for the first, however many, 1, 2, 3, 4, 5, 6, 7, 8, first 9. All right, I'm gonna go ahead and connect those. Smooth curve. And it starts at 4 and it slowly winds its way down to 0. All right, so that's that first piece. All right, now go ahead and fill in the rest. Plug in 210, plug in 225. Plug in 240. You have a smoke, you got them?
Yep.
All right, what you got?
0.3, 0.6,
1, 2, 3, 3.4, 3.7.
Okay, now I don't have 360 on here, but 360 has to be the same as 0. So think about where 360 is. All right, so let's plot those 0.3 for the 210, 0.6, and then what do we say? 1, 2, 3. Oh, I missed one. Which one was 3? 300. 240 is 1. Oh, I missed, hold on here. I missed 225, sorry. 225 is 0.6. And then we got 1, 2, 3, 3.4, 3. Whoops, I missed it again. 3.4, 3.7, and then it's going to hit back at 4. Okay, so it looks like that. All right. Polar graphs do not look anything like rectangular graphs. Okay. One thing you got to think, like for a rectangular graph, like y equals whatever 2x squared or x squared plus 8. You're plugging in x values that go from negative infinity to infinity. Like it goes all the way across the x-axis. That's not necessarily true here. We're plugging in angles. So we're plugging in 0 to 360 on that one. All right, go ahead. Same thing here for 1 minus 3 sine of theta. Go to 180. Go to 180 and then just kind of hold it for a second. All right, Aaron, you got them?
Yeah,
All right, what do you got for 0 degrees?
0 degrees is 1.
Okay.
Negative 1/2.
Negative 1/2.
Negative 1.1.
Okay.
Negative 1.6.
Okay.
Negative 2.
All right.
Negative 1.6. Negative 1.1. Negative 1/2.
And then go ahead and put in 180 as well.
1.
All right, make sure you got those. I think those are right. They look right to me. Now, we're going to run into, not an issue, but we got to make sure we know how to graph this. It goes 0, 1. And then, all right, so we're going to plot that 0, 1, which will be right there on that axis. Now, where is 30 degrees negative 1/2 or negative 1/2 30 degrees? So you go to 30 degrees, you go through the origin, and then it's going to be on the other side. And then 45. What's happening at 45? What was that one? Negative 1.1? So 45 is negative 1.1, so you got to go through the origin. Here, 60 degrees is negative 1.6. 90, I believe, is negative 2, which is actually going to be where 270 is. 120 should be negative 1.6. Let's see here. It's easy to get mixed up. 135, I'm hoping is negative 1.1. 150 is negative 1/2, and then 180 is 1. All right, so now it gets really confusing if you don't go in order. So sometimes you might go piece by piece. What's happening though how do we connect 0, 1, and 30, -1.5? Those got to be connected. So it's not obvious. What you do is you always plug in more points. Since you haven't dealt with this a lot, let's just take a look at what's going to happen, and I'll show you. So I'm going to plug in every 5 degrees. I'm going to do 1 minus 3 sine of 5 degrees. And that gives me 0.7. So I'm just going to estimate here. So at 5 degrees, I got about 0.7. That's pretty close there. And then I'm going to plug in 10 degrees. 1 minus 3 sine of 10 degrees. And I get about 0.5. So at 10 degrees, it's about 0.5. What happens at 15? 1 minus 3 sine of 15. 0.2. Where's it heading? It's heading to 0, right? Now, I'm not sure exactly where it's going to get there, but at 15 degrees, it's at 0.2. And what happens at 20 degrees? 1 minus 3 sine of 20. Now it's negative. And then what happens at 1 minus 3 sine of 25? Negative 0.26. So now at 30 degrees, it's negative 0.5. So here's what's going on. It's above the x-axis, but barely, but it has to go through 0. So when we go from a positive number to a negative number, it's got to go through 0. Can't just randomly skip through there. So, and at 0, that's the origin. That's 0, 0. And now everything else I can connect. So it barely goes above that axis. And now watch your order. We get to 150. And then that's at -1.5. But what happens at 180? It goes back to positive 1, right? Well, since it went from a negative to a positive, it's got to go through 0 again. And so you'll get it where it just barely goes above that axis. All right, so that's that. We can make a little loop-de-loop there. All right, well, what happens for the rest of it? Plug in. Go ahead and plug in 210, 225, 240, and then fill in your table. And let's see here. Maggie, you got them all?
Yeah.
All right, what do you got there for 210?
2.5.
Okay.
3.1.
Okay.
3.6.
All right.
4.
Got it.
3.6.
Okay.
3.1. 2.5.
2.5. And then and I know I didn't ask you, but at 360, it'll go back to 1. All right, so let me take it here. Look here. We said at 210, 2.5. So 2.5. At 225, I believe she said 3.1. 3.1 should be about here. Whoops, hold on. And then 3.6 at 240, 4 at 270, 3.6, 3.1 at 315, 2.5 at 330, and then it goes back to 1. And so there we go. So now, it doesn't look the same as the last one. Okay, it had that inner loop, but that's going to be our final graph, okay, between 0 and 360. These are, I forget, limacons. We'll go with that. Okay. And the first one has that inner loop, and the second one we call cardioid, because you health tech people know it looks like a heart. So it's a cardioid. So we can change that. Now, Jacob, you figure out how to graph these on your calculator yet?
I don't know how to do it on the other calculators. Mine's a little different.
Oh, on the other ones? All right. You can graph them on your calculator. Okay, but you got a problem. It says y equals, we gotta go to a different mode. So we're gonna go to, let's see. Hit mode, go to the fourth line down. And we want polar. It's either gonna be POL, or if you got a newer one, it'll say polar. That says function, that's what we're normally, and that's like y equals x, y equals 2x. PAR is parametric, we don't deal with that. POL is polar, so hit enter. Now go back to y equals, and it doesn't say y equals, it says r equals. Okay, now let's type in, what was that last equation, 1 minus 3 sine of theta? Okay, so 1 minus 3 sine. Now, where's the theta button? Is where the x button is. So you just hit x and it knows, since we're in polar form, it's going to put in a theta. Okay. Now, I'm not sure what's going to happen. Just hit graph. Oh, yours says x?
Yes.
Oh, okay, well then that's all right, I guess.
I'm just trying to do line thought. Yeah, it's all right.
Okay. Positive 6. Yeah, go back.
What has?
Is this button? No? That's what it is.
I got a middle.
Oh, no. Well, I mean, obviously it works, but just no. Fine. Did it show? It may not have showed up. Did it show up?
Yeah.
Yeah. Did it look like ours?
Yeah.
Okay. Let me hit graph. There it goes. You see it?
Mine's taking it sweet.
Okay. Now there's a lot more going on with the polar graphs and the rectangle. Go to your window. Go to your window. We have an extra set of parameters we need to deal with. In the top it says theta min, it says theta max. You have to tell what degrees to plug in, and then it says theta step. Well, just like anything else, it plots points and it connects them. The theta step basically tells you how many points you're plotting. So 0 to 360, and then I'm going to go every 5. That's usually good. Now, just don't do this, but just watch. If I put in, let's say I put in 60, that means it's going to plot a point every 60 degrees. Okay. We'll see what it looks like. Doesn't look anything like we had because we haven't plotted enough points. Okay. Now, you might be negative 10 to 10. That's okay, but to give it to see it a little bit more, I just shrunk it to negative 5 to 5, depending upon what the graph is. So, okay. Yours not working?
It's just a line.
All right, let me look at it. Okay. Right here, what was that?
There it is. How did you do that? I don't know, I just did two things. I don't know how that did the whole thing from here. That's okay. I don't know.
Oh, 90 is just a.
Whatever. Yeah, that's fine. Oh, wait.
All right, do a little, listen up here for a second. Do a little experimenting. It says if A over B is less than 1, A over B is less than 1. So that means if A is smaller than B, so that's a 1 or a 2, you're gonna get an inner loop. If A over B equals 1, that's where you get the cardioid. And based upon if it's a sine or cosine, it'll shift it or which direction it is. So just try a couple of different numbers there. And I'm just gonna do a quick walk around, make sure everybody's good, and then see what kind of, and if you change those numbers, like how big it makes it or how small it makes it. So see if you can make a couple cardioids, a couple inner loops for that. Good. Good on graphic.
Yeah, I think so.
There it is. It's a little thing.
No, I Split it off.
Three things.
So is it already like the cosine line and then they will do it?
That was a big, look at that.
Huge.
That's a kind of lot. I don't even.
Okay.
It's like my
I'm gonna
niece.
do. I just want.
It does, yeah, it looks like my niece. and I'm
Must take it to that.
Yeah, it's just all right, so what else is going on here? Now listen up. If I change my theta step to 1, what's the only thing? Will it be a more accurate graph or less accurate? It'll be more accurate. How many points is it actually going to plot? 360. Okay, it's just going to take longer. Okay, it's just going to take longer. So like I said, just for intent, and it doesn't give you that much better of a picture. Okay, because usually 5 works. But you can change that to whatever. If you make it too big, then you're running into troubles. All right, go to y equal, clear that out. Make it 4 sine of 2 theta. Do that. And graph.
Whoa, okay.
Okay. So you kind of get a butterfly, 4-leaf clover, whatever you want to call it. Okay, so this is totally different than what we had before. If you change the number on the outside, that kind of changes its width, how big it is. The number on the inside is going to change kind of how many branches it has. So if I make that a 4, so you can do that.
I like this.
Oh, yeah.
These are called Rose curves. If that number on the inside after the cosine or sine, it could be cosine, is even, it doubles the petals. If it's odd, it has that number of petals. So if I make this, let me make it 5 cosine, and if I make that 5 theta, it's going to have 5 petals. Okay, 5 cosine, 5 theta. Now, if you change it to, let me do 5 sine, 5 theta. Now, mine doesn't look as cool because I don't have color like you guys. If I do that, it just rotates it a little bit. So you can make all kind of little designs or pictures from here. On here. So this is a rose curve. All right, one more I want to cover, and I want to see if you can predict what this will look like. And All right, I'm gonna do R equals 0.01 theta. R equals 0.01 theta. Predict what that's gonna look like. Okay, so whatever the angle is, you're multiplying by 100 and then graph it. Now go ahead, once you get a mental picture, go ahead and graph it.
Go to primary. No, go to window. Data maps.
This is gonna be a spiral. Now for this one here, you can increase your theta max. It doesn't have to stop at 360. So I can make it, if I make it go to 720, it's gonna do full 2 circles. Okay, it's gonna keep getting wider. Now to help me see it better, what I can do is I can change, instead of 0.01, I can make that smaller. I'm gonna go 0.005 theta. And my window 0 to 720, you can see it'll do 2 full cycles. It's just gonna keep getting wider and wider. Okay, and I can keep going. If I want to do another cycle, I can go 1,020 or 1,080. And then you got that. Okay, so there you got a spiral. So you get all kind of different shapes with polar graphs on here. We're not going to worry about the lemniscates as well, but these are the spirals. Now they give you a little overview in your book of 7.6. You just need to be able to graph given the points, and I'll show you a little bit more tomorrow. But like you said, there's different ways that you can go about, and the graphs will look a little bit different. All right, what I'm going to do now is I'm going to give you the practice test. You get done however much as you can. It's not going to be, you're not going to turn it in. You will turn it in before the test. But whatever you get done today, whatever you have time to do is fine.
The data max is 99,989. What's your action? Negative 1,000.
It really doesn't. It doesn't make sense.
It's still going. How? What is it? It's okay. See, that doesn't work because it's a window. That window. Data. Mine doesn't have water. No, 90 degrees now. And water cool. I'm not. Water cool.
Mine was 0 charge. It did better.
Hey, a couple of things while you guys are messing around with your polar graphs. And for everybody else,
Mine doesn't do.
skip number 5. There will not be any area problems on the test.
Oh.
Okay, and then here are the three formulas I will give you. I will give you the law of sines. So sine of A over A equals sine of B over B equals sine of C over C. I give you the law of cosines. I'll just give you one form. If you need to rearrange it, that's fine. And then I'll give you the formula to find with the dot product and the angle between vectors, but I'm going to give it to you in this form, that the dot product equals the magnitudes, the product of the magnitudes times cosine of the angle. You're going to be responsible for just dividing by the magnitude. You should be able to do that. But I'll put those three on the top of your test. Okay, and we'll go over that a little bit more tomorrow. Like I said, do as much as you can here today. If you get to it tonight, that's fine. If not, we'll do a few things in class, but you'll have some time in class to work on it. All right, any questions?
What day is the test on?
Monday,
The
sorry. Monday.
Monday.
Yeah.
Yeah. AP Chem test.
Oh,
It's okay, I don't do well unless it is.
Hey, myself, looks like
Alright, I'm putting it on.
I should have thought about
Just try it a little bit.
Oh.
Yeah.
Catch fire.
It's just for graphic.
Here, I've got an idea. Alright.
Wait, no, it's actually, so I can fill it up fast.
Yeah, it's gonna take a little bit of extra.
However,
Okay. I want to see how low. Okay, that's not good.
Oh.
So you can't have it. No.
We're asking